Hello and welcome to a quick tutorial on how to get started drawing force diagrams. My name is Wylam and I'm going to go through this concept for you. First up on the agenda, we're going to go through the process that you should follow when doing a force diagram problem. Then we're going to go through all the different types of forces. Then I'll give you a quick little mnemonic on how to remember all these forces. And finally, we'll do a practice problem. First up on the process, you have to identify your object. When given a practice problem, normally it will be pretty obvious, but make sure you know exactly which object you're drawing the force diagram on. Then, make sure you know each force that's acting on this object. Don't forget to read through the problem multiple times and underline forces that are given in the problem. Finally, once you know your object and you know which forces, make sure you draw every single force on your object in your diagram. There are 6 different types of forces that are commonly seen in force diagram problems. The first one is an applied force. This is a push or a pull, pushing a box, pushing another person pushing you. And then there's gravity, which is normally denoted by mg, as seen in the top left image. Then there's friction, which is normally counteracts an applied force or is present whenever a box is moving or your object is moving. Then there's normal force, which is always perpendicular to the plane that you're on, but I will talk more about this at the end of the video. Then there's tension, which is normally a force due to a string or a pulley, which you can also see in the top left image denoted by T1, T2, and T3. And finally, there's spring forces. These are not commonly used in force diagram problems, but they can be present. They're most common in potential energy problems. You might be wondering how to remember all these different forces, as I just threw 6 at you all at once. Well, the last 5 can easily be remembered by a simple little mnemonic. You have gravity starting with G, friction starting with F, normal starting with N, tension starting with T, and spring starting with S. If you take all these letters, you can make a simple little mnemonic: good friends never take your snacks. So if you can remember that good friends never take snacks, you can remember that you need to look for a gravity, a friction, a normal, a tension, and a spring force. Now, let's remember our steps. Pause the video and make sure you can remember step 1. Step 1 is identify the object. Now, let's try and think about step 2. Step 2 is determining the forces. Now, think about step 3. Step 3 is drawing your forces on the diagram. This is actually what we'll be doing next in our practice problem. Here is practice problem number 1. I'm going to read it out to you now. A rightward force is applied to a book at rest in order to move it across a desk. Consider frictional forces, neglect air resistance, then construct a free body diagram for the book. So, first thing that you want to gather from this problem is what is our object and what are the forces. So quickly pause the video and determine what our object is and what are all the forces acting on the object. If you said that our object was a book, you'd be right. And if you said that there were 4 forces, applied, frictional, normal, and gravity, you'd also be correct. Now we're going to move to drawing our diagram. Now, when drawing a force diagram, you don't have to do this step, but I recommend turning whatever your object is. If it's a box, a book, a ball, make sure it's just represented by a simple box on your diagram. It makes everything easier. So you can see on this slide, I turned our small little red book into a box that just says book. Now let's draw on our force arrows. First, we're going to have an applied force to the right. Then we're going to have a friction force to the left. Then a force of gravity down and a normal force upwards. Check and see if you had the forces correct on your diagram. Next, we're going to move on to our second practice problem, which is a little bit more complicated than the book on the desk. Now we have a pulley, 2 boxes, and the F denotes an applied force. Please note that the boxes are at rest, and we're going to be making a free body diagram for box A and box B. So starting with box A, make sure you know your object, make sure you count all your forces, draw in your forces. Then for box B, you know your object, you know your forces, and draw in your forces. Pause the video, and next we'll move on to box A. For box A, hopefully you had 4 forces acting on it. You have a tension to the right, a normal going upwards, a gravity going downwards, and a friction to the left. Though the box is at rest, the tension force is still moving to the right, being counteracted by a friction force. This is due to the applied force on box B. Then you have your gravity force, which is almost always pointed downwards, and since we're on a flat surface, the normal force was going upwards. Now, moving to box B, this one is a bit more complicated. Since we were already given our applied force to the right, hopefully you had that drawn in. Then we have an angled tension force moving with the pulley, which is in the opposite direction of box A's as they are opposite forces. Then we have a gravity force going downwards, and unlike the book problem, we have a normal force which is not perpendicular to gravity. This will be noted in the next slide as well, but the normal force is at an angle because it is perpendicular to the face the box is on. Now I'm going to give a final note about normal force. With the diagram we just created, our normal force was perpendicular to gravity. However, this is not always the case. As I said before, normal force is perpendicular to the plane you are on. So if you look at the image to the right, rather than the normal force being straight up, it's actually going to be perpendicular to the slope, so pointing to the top left. Thanks for watching, and I hope you learned a ton about creating force diagrams.